Okay, so up at the top it says if you know any two sides of a right triangle, you should be able to use the inverse of one of our trigonometric ratios to solve for any missing angle. All right, give the measure of the acute angle theta to the nearest degree. So not only does trig help us solve for sides, which I'll show you in the bottom question there in number 5, trig also helps us solve for angles. Okay. So in number 4, it says give the measure of the acute angle theta to the nearest degree. So in this case, we want to know what theta equals. So we say theta equals sine inverse of 3/10. And hopefully you remember this from geometry. When you solve for an angle, you have to use the inverse keys. All right. Just make sure your calculator is in degree mode. So if you hit your mode key next to your second key, make sure you're in degree, not radians, okay? Otherwise, this will not come out in degrees. It will come out in something called radians, all right? So our theta is equal to, once we type this in, 17.4576, okay? Because they said nearest degree, go ahead and underline the 7, look next door, and we'll say theta equals 17 degrees, all right? In part B, again, they want us to solve for theta, so we say theta equals tangent inverse of the square root of 3 over 3. And we'll say theta equals, and we'll type it in. All right. Just make sure that you close the parenthesis after the top 3 before you divide by 3. All right. And when you hit enter this time, it comes out to be 30 degrees, and we don't need to round it. In part C, we're solving for theta, so we'll say theta equals cosine inverse of 0.5, or 1 divided by 2, if you like it as a fraction better. And we'll type it in, and it comes out to be 60 degrees. And again, doesn't need to be rounded. Right? Last one, solving for theta. So we'll say theta equals tangent inverse of 3, or 3 over 1 if you want it to be a fraction. Right? And when we type it in, this one does not come out nice. 71.5650 ... To the nearest degree, we're going to say theta equals 72 degrees. All right, so solving for an angle is super quick and easy. As long as you know the trig function and the ratio of the two sides that trig function uses, you can solve for any angle. Okay. All right, so coming down here, sometimes they use the words angles of elevation and depression in our question. Okay, and I'm going to show you how to solve for a side and review it from geometry from last year. So number 5, it says Amelia standing on a beach looking up at a lighthouse whose base is 650 feet from where she is standing. If the angle of elevation, and right there that tells me I'm working on a right triangle, and the angle of elevation means to look up. So we have to be down here. So Amelia is down here and she's looking up to see the top of that lighthouse. Okay. And that lighthouse's base is 650 feet away from where she's standing. So our 650 is going to go on the bottom of the triangle. And when she looks up, she is looking up 52 degrees to see the top of the lighthouse. So that's the angle of elevation. To the nearest foot, how tall is the lighthouse? So hopefully you know height is going straight up and down, okay, or vertical. And so now that we have everything from the question labeled, we could go ahead and say it. We're reading from this angle of 52 degrees. This x is therefore our opposite side, and the 650 is our adjacent side. And hopefully you know that the trig function that uses O and A, okay, is tangent. And so we'll say tangent theta equals O over A. And we're going to keep tangent. Remember that theta is an angle and that our angle is 52 degrees. And that our opposite side is x over our adjacent side, which is 650. Okay. We are not solving for an angle, therefore we will not use our inverse keys. Instead, we are going to put this over 1 and cross multiply. When we solve for sides, we have to cross multiply. All right, and we end up with x equals, oops, I put a degree symbol on my 650 and that's not right. Sorry about that. It's actually 650 feet, which I don't need a label on. Okay. So when I cross multiply this way, I always put what's on the bottom first and then times my tangent of 52. Okay. All I have to do is type that right into my calculator, 650 times the tangent of 52, and that's just regular tangent, not inverse. Remember, inverse is used for solving for angles like we did up in the 4 questions above this one. Once you type it in, you also have to be in degree mode, all right, which you should still be from the top 4 questions. you should end up with this number here. All right. Question says to the nearest foot. So we'll underline the 1 and look next door, and we're going to say 832 feet. And that is as tall as the lighthouse. Okay, it is. All right, number 6. Similar question, but this says the plane flying at 31,000 feet begins its descent 125 miles from the airport. If the angle of depression is constant, find its measure to the nearest tenth of a degree. So angle of depression, again, is something you learned in geometry. That happens up at the top of the triangle, outside the triangle. It's when someone up here, like let's say the pilot is looking straight out. Okay, that's his line of sight. But then all of a sudden he looks down to see the airport. The angle he looks down is called the angle of depression, depression meaning down. Okay. However, we can't solve for that angle up there because it's not inside our triangle, but hopefully you guys remember a little bit something about geometry and alternate interior angles. And so that angle up there is the same angle down here. All right, so I won't use this angle anymore. It has the same measure as this one down here based on parallel lines cut by a transversal, and that alternate interior angles are congruent. So this angle up here is the same measurement as this angle down here. Okay, but I like this angle down here because it's inside my triangle. I just had to be careful, guys. And then I have feet and miles, and 2 different dimensions is no good. So we're going to go ahead and realize that there are 5,280 feet in 1 mile. And if I have 125 miles, then that would be 660,000 feet. And now everything's in feet, and I can go ahead and continue to do what I'm doing. All right. So because my angle is down here now, that makes 31,000 feet, my opposite. And it makes 660,000 feet on the bottom, my adjacent. And O and A make tangent. So we're going to say tangent theta equals O over A. That, remember, theta is my angle, and that is what I'm trying to solve for. And that my opposite side is 31,000, and that my adjacent side is 660,000. Okay, because I am solving for an angle, we're going to use our inverse keys and say theta equals tangent inverse of 31,000 divided by 660,000. And we're going to type it into our calculator, making sure we hit that inverse. So second tangent, and then type in our fraction. And we should end up with 2.68918. And they said to the nearest tenth. Okay, so we underline the tenth, look next door, and we'll say 2.7, and it's an angle, so degrees. And that's the angle that the pilot looks down from up in the plane to see the airport. All right, so hopefully there's a little bit of a quick, good review of trig, all right? So you basically have to know your 3 trig functions, okay, that an angle always follows the trig function, and that it's equal to a fraction of 2 sides of your right triangle. Okay, and depending on what trig function, each one uses 2 different sides in a different order. So be careful that you know those. Then if you're solving for a side, you cross multiply. And that if you're solving for an angle like up here, that you use your inverse keys. All right. And that if you have a side of your triangle missing, that you use the Pythagorean theorem to find it. And so if you know all those and that's what you got out of today's lesson, you should be all set to go. All right. All right. I'll see you guys on day 2.